Okay, good afternoon everyone. So today we will start our lectures number 9, and most of you received the feedback for the multiple choice and the short answers. So regarding the programming, we're still waiting for them finalize the marking for the programming part, then soon we'll post the feedback for the programming, and also we will post the solutions for the lab test too. Last time we discussed the pattern matching and regular expressions, and also we discussed the JUnits test. Today we will go over collections, and hopefully we will have a time at the end of this lecture to discuss computational complexity and big O notations, where you have a sense about how much cost in terms of time your programmer will be taking, or when once you execute your program, you can see what's the difference between two implementation. You can quantitative this difference. When you see two solutions, both are give you the correct results. So the computational complexity in terms of time, we hope, can give you an idea this implementation's better than the other implementation in terms of time. But before we discuss the computational complexity, let us go for collections. Last time we discussed interface, and regarding the interface, we say that the interface, it's a class, but we define it as a public interface, not public class. And the difference between the interface and regular class, you list all the header of the method inside the interface without the body, without the definitions of the methods. As you can see on this slide, we have a drivable interface, and we have 4 methods that are related to this interface. So whenever we need to implement this interface, we have to provide the implementation for a method public void start, and also forward 10 with some angles, and stop. So these are 4 essentials methods that are come with the interface called drivables. And we saw last time that we have a bicycle. Bicycle is a moving objects, and we define it as public class bicycles, and we would like these bicycles to implement the drivable interface. So in your application as a Java developer or apps developers, you would like to have something like that. So whenever you create a new object, you want the behaviors, because this method control the behavior of the object. So now the bicycle is an object, and the behavior of this bicycle guarantee will have these 4 methods: start, forward, 10 with some angles, and also stop. So these 4 methods are mandatory to be there, and you have to provide the implementation for them once you decide to say bicycle implements drivables. Now, the class, the object, can implement multiple interface. You can implement a drivable interface, you can implement clone interface, you can implement comparable interface. So you can implement multiple interfaces, and each interface comes with a certain rules and a certain behaviors gonna be added to your objects. In this example, or a basic examples, we have bicycles and only implement single interface. This interface is drivables. And again, we saw that we have a car is a moving object and also implemented drivable. So we have 2 objects that are implement the same drivable. Now once you say I implement the drivable, you provide the implementation for these 4 methods, and so you can add any other extra methods that are related to your object that not exist on the interface. So doesn't mean if I implement a drivable should not add any extra method. No, I can add extra method, but I should provide the implementations for the interface methods. So this is a diagram, show you the interface is called drivables, and we have bicycles and cars implement this interface. Why we give introductions for this? Because when we go to the collections, we're going to see that all the collections that we're going to work with, it's implement a particular interface. All of them is come from the collection interface. So let us go to this example to highlight one of the important things here. We define a car object, car A, as car, of type car, and then we give a name of the variable is a car A. Then we say a new car, and we give the name for the car. And we use start, train, and then forward. And then you can see here in the second one, we use a drivable. Drivable is an interface, is not a class. So drivable, we can use it at the left side as a reference type. So we use a drivable as a reference type. We cannot create object from the interface. We can create object from the class. So we can use drivable as a reference, and we have car P, and we create a new car objects. Again, we can work with the car P as car objects. The only thing that we reference to the car using a drivable interface. This is the output. Now, what's the difference? If we would like to summarize what the difference between the class and the interface, we discussed this last time. We said that both are user defined. You as a programmer, you decide when you're going to create an object and when you're going to create an interface that control the behavior of a certain object. And in the interface, you have a set of methods without implementations, just a set of methods, the header of the method. Now, in the class, you have data and you have methods, and the methods are implemented inside the class. So again, there's no implementation for the set of the method that inside the interface, while on the class, you cannot leave any method without implementations. Now, you cannot create object from the interface, while you can, that's the main reason why you create a class, to create an object from that class. So once you create the interface, you cannot create object from interface. Like in this case, we have a drivable is an interface. We say drivable car C equal a new drivable. You cannot do this. This is illegal to create an object from the interface. You can use the interface as a reference type to the left side. And whenever you need to use a new keyword here, new, you have to use it with an object that allow you to create classes. Like, don't get confused with the math, for example, class. Math is a class where the Java expert is created, and they not allow you to create an object from it. It's not an interface. It contains some implementation for the methods, but we cannot create object from that class. And by definition, whenever you create an interface, you cannot create object from that interface. Now, after this brief introduction about the interfaces, we're going to go to discuss the collections. Collection is very powerful tools that the Java expert provided for us. And sometimes it's actually the critical reasons why you decide to use Java for programming, because it's to provide you with a rich set of collections that meet your needs for a certain apps or a certain applications. So before we dig deep, let us discuss some abstract things. When we say abstract data type, every time we define a new object, when I say new object by saying defining a new class, we are actually adding a new data type to the set of Java. Like bicycles, it's a new class. When you decide to create a class called bicycle, you actually create a new data type and you add it to the set of data type inside Java. This data type contains some fields, attributes, and also behaviors, some set of methods. And we used new keyword to create a new object from this data types. A string is an object data types, while int is a primitive data type. You cannot use a new int. If you would like to use an object version of int, you go to integers, which is the wrapping class that allow you to create an integers objects. So we can use this data type, a new data type, all over inside our program as we are using doubles, and so we're not gonna make any distinction in terms of the manipulation. You create a bicycle class, you create a new bicycle, you treat it as you are string data types. Now, there's some constraints about creating a new data type and manipulating this data type. You will have more details later on other courses. For example, a class person that we create through these semesters. We have person, we have name and ID. Both are of type string. Now, as you can see, string is an object. So this is where we have a nested object inside the person. So I decide to create a person class that's contain 3 attributes or 3 fields: name, ID, and age. As you can see, the name and ID and age, all these are the name of the attribute, and each attribute has type. And for the name, the type is a string object. For the ID is a string object. For age is an int. And there is a public or private that allow you to access. Whenever we're not putting public or private, it will be what? Can anyone tell us what is this? The access? This is a private. So nothing from outside this class can access these fields. Is that right? Because they are private. Within the class, I can access them freely. But outside, I cannot access the name and ID. What about age? Within the same package. So any class within the same package where the class is person is defined, you know, at the end, as we discussed at the early lectures, that a class person gonna be actually transferred to a file in your hard disk. Person.java. This is the file. And this file will be inside a folder or a directories. Now, any class within this directory, it's a package, will be. So any class within that will have access to age attributes directly without any methods. So directly I can say person dot or the object that I define. And as you can see, these are not statics. So whenever you define a new object, you have to give a new name and a new ID and also age. Because these are object attributes related to the object. If you define attribute or a field that are static, it will be related to the class. So you can call it with the class name. How we can create an object from this class? We have to do what? Define what? Use a new. We have to use a new, but we have to, as a developer, we have to provide the constructors. Yes, in our implementation, to be able to use a new keyword to create an object from this person class, we have to provide the constructors. The constructor is a special method, you can call it, but some people, they say, we should not call it a method. It's a constructor. That's why they give a name for it. It's a constructor. Some people, they say a method called constructors. No, a constructor is not a method. I'm going to that direction. A constructor is a special. It has a special purpose to create an object for you of type person. As you can see here, public, there's no retain type. Even void, there's no retain. Yes, the constructor does not retain anything. I cannot use void with the constructors. The constructor has the same name as the class. The class is person, the constructor is person. Now is the list of input for these constructors, which is control the way that we need the end user to create a person object. I need name, I need ID, and I need age. And you can see once I receive the name, I'm going to assign it to name. ID, I'm going to assign it to ID. And age, I'm going to assign it to age. Now, I would like you to make sure that this, what is this here is. And I don't use this here. Why this is here? Why I'm not using this here? Why I'm using this here? Yes? Mm-hmm. That's right. So that's what we call a shadowing behavior. When the attribute of type ID received by the list of the constructor, it has identical names for the class attributes. So the parameter name inside the argument here, it's ID, and there is ID. So to make this distinction, the priority for the parameter inside the method, to let know that this is this .id, which is the one that belongs to the object that you are creating, we use this. Why we're not using this with name? Because this name is different from the one on that is N capital, here is N small. This is a pointers provided by Java to you, always point to the object that is currently being constructed. Now we are currently constructing an object of type persons using this constructor. So we can use this to reference to that object, and we can access all the attribute of that object. We can provide get name, get ID, set name, get age. We can have this methods to allow us to interact with the attributes. So we somehow tell the end user, you cannot go directly and set the name by using your object dot operators. You have to call set name method, and you give us a new name, and we're going to set it inside this method. So you control the process of get and set using get methods and set methods. Whenever you create a new object, it's good to have some set method and get method that control the way of creating or changing attribute inside your objects. Also, you can provide toString if you would like to print the object to the user. If the user is asking you to print the object, you can ask toString. And toString is an override method that's come from the object class, which is the parent for any class you create inside your app or inside your applications. And toString, it's retain a string data type. So a string data type will be retained to the user once I use the object person inside a print message, like system.out.print. Once I use the person data type there, object of person data type, I will print this string. Equals, it's another method that allows us to check if two persons are equal or not. And as I mentioned to you, equals, there is a method that is already implemented for us by Java expert inside the object class, which is the parent of any class that you create. It's going to check for equality if the two objects are referring to the same object by looking at the memory locations. Are these two objects are pointing to the same memory location? If yes, we say yes, true, they are equal. Otherwise, we say false. Now we say that whenever we ask for equality, if two objects are equal or not, we say, I'm not going to check the names. I'm going to look at the ID. If the ID is equal, I'm going to say these two persons are equal. Otherwise, I'm going to say false. This way, I'm going to look at this equal, others. Other is the one that I am sending here. It's a type objects. If you go to the clip, to the Android Studio and right-click and say generate, and you want to generate equals, it will ask you to generate equals and hash codes. But for the purpose of this course, it's important to understand what is equals here. Equals is receive objects and is asked if this object is pointing to the same object, then we return a true, which is the standard implementations. Otherwise, if the other is equal to null and get class, the type of this class is not the same as the class of the other one, we return false. Other than that, we're going to cast other, because it's of type object, we're going to cast it to person, okay? And then we ask if this ID dot equals. We rely on a string data type to check for equality, because ID of string data types. This is a pointer, point to the object currently being constructed. So this inside the class is point to the object that you are working with. So when you send, you say person, the object person dot equals. Like you define a string, you say string, this is string, dot equals the other string. So this now is pointing to the object that you are using the equals method inside it. So here, this is pointing to the object that you are working with. You have the person and you want to check if this person equal to other person. So this is pointing to this person that you are working with. Now, I can compare two persons based on the ID. Okay? But let us just take this for equals or not. This is how we define a class. We already saw this in the previous lectures. We define a student class where we have two attributes, student name and student ID. We create the constructors that allow us to construct a new students by receiving a new name and a new ID. And also we have get name, get ID, and we have toString to print it out to the users. We can check if two students are the same by checking their student ID. As you can see here, the student ID is int, which is the primitive data type. So once we go inside equals, we can use equal because it's a primitive data type. It's not an object data type. In the previous class where we have a person, we have a string data type. So we have to use dot equals to make sure these two strings are the same. Here we have a primitive data type of type int. So we use equal with this to check if these two students are the same ID. We have a rectangle class. All these is objects that we create throughout the semesters and we add to the data types of Java. Each time you create an application or an app, you decide to create a new class, you actually create a new data type that you need to add to set of data type of Java. Rectangle, we have width and height. We construct a rectangle by receiving a width and height. We get height and get width. We can calculate, we have another set of method. We can calculate the area and other attributes for the rectangles. We can check if the two rectangles are equal or not by checking the length and also checking the width of rectangles. So all these classes we create, we create a new data types. We need to store many rectangles, many persons, many students, and to start working with these data types, most of the time we need collections. Yes, we can use arrays of person data types. We can use array of student data type. We can use array of type rectangle, because now once I define a rectangle, it starts to be the same as doubles or int or a string data types. Because I create this class, I will work with this class for my application as I'm working with the double and string and all other data types. Okay, so we have already saw the arrays as a set of collections allow us to store many objects, and we can sort them, we can look inside these arrays, okay? And sometimes people are viewing arrays as an object data types. Most of the collections that we're going to discuss today, and I think all of them, is inside java.util. All of them inside this package. So there is a folders, Java, inside it there is a subfolder called utility, and this abbreviated by UTIL, and inside it you have a set of collections. All the collections that you're going to work today is inside this package. Now, to look at the top view or the top architecture of the collections, we have ArrayList, LinkedList, we have HashSet, TreeSet, we have TreeMaps, we have HashMaps. All of them we're going to come across today. And all of these, and there is actually a large set of collections. There is a vector collections and all other that. All of them again from java.utility. Now, collection is a group of individuals element, often governed by the rules that apply to them. So you can store, you can collect objects that are the same together in one group. The classes in the Java collection framework fall in three categories. Whenever you want to discuss the collections, as a top view, you look at the three categories. The first category is the list, where you are interested on the orders. So you list things based on the time, the first come, first serve, for example, list, and you are important about the orders inside this list. Okay? So list is an order collections of values that allow the client add and remove elements. So if you would like, this is a top view, this is where the decisions gonna be made based on applications. If you work with a certain applications that require to create a collections, and inside these collections you want the client to add and remove based on orders of the elements, okay, and you are receiving an element incrementally with time, it's good to use lists. As expected, ArrayList fall within these categories. A list must hold element in a particular sequence. You cannot switch elements inside the list. But let us see more. You can do something by calling some other methods. A list holds objects exactly as they are entered. You can change that, or without any reordering or editing inside it. So as the default things, if you don't intervene, the default thing as the object is added to the list, you always add at the end of the list. Okay? You always add to the end of the list. So we have the list. Now we have the set. The set, the order is not important as long as you put things together. Like you go, and these are the textbook for the previous semester. This is the textbook for the new semester. You put them on one set. You don't important for you the order of these textbook. As long as you're important for you, this is the set of the textbook that I'm going to work in this semester. These are from the previous semesters. Okay? So unordered collections of values. The important for us is to check if the element inside the set or not. We not allow the duplicate inside the set. It's like the mathematics. You cannot allow the duplicate inside the set. That means in the list, you allow the duplicates. So if you are interested in your applications to put things together, you're not interested in the orders. You are interested to ask if this element belongs to this set, exists or not, use set. Okay? What's the difference between set and list? List important about the order and allow you to have a duplicate items. While in the set, the order is not important and we cannot have a duplicate items inside the set. So the set are accepting one of each object and it used internal mechanism to sort them out. So doesn't mean if you add the element, it will be added always to the end of the set. You might add elements in order for you, but once you print it out, they will be in different orders because they have internal mechanism to understand where to put the elements in which order. So in general, if you decide to use the set, you only concern about whether or not something is a member of that set or not. You're not interested on the order of the elements. The other category, so we have list, we have set. The other category is called the map. You go to the library, most of you go to the library, you have the value related to the book. You go to the value, you see the value, and this code numbers inside the computer allow you to go to which shelf, and you can find your book at which roof on that shelf. So you know exactly where is the book by looking at the code. That is the map. You put the value and the key associated with the value. Both together create one entry. So in the map, we should have two associations. Keys associated with the value. Key associated with the value. Whenever you are working with an applications that require key and name, you use a map. Can anyone give us an example? Barcode. Your cell phone. Your cell phone. You store your contacts. You memorize all the phone number of your friends. It's very hard. So even your friend, his name, you write a nickname for him. Best friend, friend A, friend P, friend from Europe, friend from work. So you store the names and then you put the value for the phone numbers. So the phone numbers is one of the examples. The phone list that inside your cell phone is an example for the map. So the structure is created by association between the keys and the values. And we have hash maps and tree maps. There's a difference between them. So whenever you are working with application where you have the key and the value together, they create one entry, and the key can be an object, the value can be an object, so you use the map. And this, the last sentence is very important. So inside the map, you can retain a set of keys. You're not retaining a list of keys, a set of keys. I don't care about the orders. I care about if this key exists or not. I should not allow inside my map a key that is repeated. Then I lose the point. So the keys are unique, so I put it inside set. Now, the values, I can have a collections, any type of collections. ArrayList, LinkedList, whatever is the collections that you have inside the values, it's okay. I can have different name, but for my friends, but with the same phone numbers. Okay? By looking to how Java organizes these lists, set, and maps inside it, we will have the collection interface. And I think most of you now understand what I mean by interface. It's a set of methods. There's no implementation inside this collection interface. And then this interface extended to list interface, to abstract collections, then a set interface. Under the list, we have an abstract list. And then until we reach ArrayList or LinkedList. So these are the classes. And this class implement the list interface. ArrayList implement the list interface. And if you want the list interface, is actually implement the collection interface. The set, we have an abstract class called abstract set. We cannot create object from this class, but we have HashSet and TreeSet. These are the hierarchy for the collections. In terms of the map, we have the map interface, and inside it we have abstract map, and we have the hash map, and then tree map. The only difference here that the hash map does not concern about the orders when you add the element to the hash map. But the tree map implement what we call it a sorted map. Sorted map allow us to work with the tree maps with a certain orders. So the hash map doesn't care about the order, but the tree map care about the order by implement a sorted map interface. Now, after we know about these three categories from the top levels, let us dig deep and look at the list. So in real life, you have companies maintain list of employees, you have banks contains list of bank accounts, you have persons, he has things to do, so he put the things on list. So a list allows you to access any of its elements at any times, as well as insert and remove anywhere from the list. That is the beauty of working with the list. So if we work with the list will automatically shift all the elements around the memory to make a need space or needs more room, can be reduced, can be increased. So that is where the beauty of the list. If you work with the arrays, once I define I need an array of 10 elements, I cannot change the length. But now with ArrayList or a list object, I can create an ArrayList empty and add a new element as I'm running my applications, and every time I'm adding an element, the list automatically make a room and space. I can shrink, extend the list as I want. The list is an abstract data types that implement an order collection of values where the same value may occur more than once. So whenever you come across an application or an app that you are interested to use an order collection of values, it's recommended to use the list. So we use the list whenever we have an object are coming in and being removed in a random orders. So as with the array, element on the general list are accessed according to the index. Again, inside the list, we can access the element through the index. Now, you can see these are the basic operation for the list, and these basic operation inside the list interface. As we saw, a drivable interface has start, turn with some angle, go forward, and stop. These are certain behaviors. So any object of type list, okay, you will have this set of operations. You can add and you give integer the index and you give an object. Here the object is referred to any object. It can be a person, can be students, you can have rectangles, strings, okay. Objects in this header can refer to any data objects, okay. So you can take a list dot add to, then you give x. X here is an object. So I have to go at index number 2 and add x. So all the element from 2 to the end will be shift. So I have a room for my elements. Okay? After this operation, if the list has n minus 1 element, it will has, after executing this operation successfully, we will have n elements. Okay? Any question? So yes. No, we cannot have a primitive data type inside the collections. Collections are restricted by the Java to use only object data types. So a string is an object data type. I cannot use int here. I can use integers with i's capitals as a full integer. It's a wrapping class. I can use doubles where d is capitals. So these are object data types. I can use them inside the collections. But I cannot use the collection with a primitive data type like boolean primitive data type or int as a primitive data type, or double as a primitive data type. I cannot use collections with a primitive data types. Keep that in your mind. Yes? Yes. We're going to come across that method. It will be added to the end. Remove. Remove with int index. Give me the index that you would like to remove. I will take it off from the list. And this diagram explains the remove method. So remove 2, I will take 9 out. In this case, if I start with the list contains n elements, when I remove 9, I will end with n minus 1. So you can see dynamically I extend and shrink the array or a list without worrying about the size. The Java maintains these operations. All these elements will be shifted 1 positions. I can set. I don't need to add. For example, I need to change a value or change the object at a certain locations. So I can take the new object and use set operation, set methods to take the index, and I can change the value. So I would like to set object at 2. So I take x and replace 9 with the x. So I'm not adding or deleting. I'm just go to the element at index 2 and replace it or change it. Okay? I can get. I don't need to delete or remove. I just need to investigate and check the items at each locations. I can get the value at index 2. I can go retrieve the object at index 2. I can ask for the size. It will retain the number of elements inside my list. So in this case, we'll retain n from 0 to n minus 1. Again, look at the index. Is the same as the array. Array always start from index 0 up to length minus 1. So the length or the size, remember, inside the list, there is no length. There is no a list dot length. There is a length in the array. But here, we have a size. And as you can see, the size is a method that retains the number of elements inside the array. I can ask clear for the list to remove all the elements at once. So I don't have any more. I can add. Just take the object and add it to the list. It will be added to the end of the list. I can remove the object. In this case, it will be going through all the objects, and the first one match with x. If I have many copy of x, the first one will match it, will be removed. Okay? I can say index of x. Again, the first occurrence of this object will be retained back. It's empty. I can ask if this list is empty or not. I can do this by looking to the size and make sure the size is equal to 0. That means the list is empty. I can ask contains. It will retain true of the object x inside the list or not. Again, the list allows the duplicates. So you might have multiple copy of x inside the list. But again, you can use contains to ask for the list. After we discuss this list, we're going to go to ArrayList, which is a particular class that can implement the list interface. So the ArrayList is inside the bucket java.utility ArrayList. So the behavior of the ArrayList is similar to the list because it's implement. So the main difference between arrays and ArrayList is, what is the difference between arrays and ArrayList? We can change the size of the ArrayList as we running the program. Once we define the arrays, we have to fix the size of the arrays. Yes, the list exists. It's empty. Yes. We can change the size of the list. Yes. You can define a list of a particular size and change the size of the list. But no, but array, you cannot change the size of the arrays once you define it. Yes, the size of the array is fixed. Once I define the array of 10 elements, it will stay 10 elements. I can store only 5 elements, but again, it's reserved inside my memory for 10 elements. Yes, I might be using only 5 elements to store, but I have the memory for 10 elements. But the difference between the array and the array list, you define an empty array list, then you start adding the element. As long as you are adding, it's shrinking or expanded inside the memory as you are adding new elements. Yes? It will change the size of the list. We can change the size of the list because when I define the array list, I can define it empty. I can add element to the array list. It will increase the size by 1. If I remove element from the array list, it will reduce the size by 1. If I clear the list, the size of the list will be equal to 0. There's no object inside this list. It's only the reference that's pointing to a null, nothing there. Okay? So when I have a declare a list, I will declare an empty list. There's no size for any list. That's the difference. When I declare an integer array of 10 elements, I will go to the memory, I will reserve 10 spaces for 10 integer. But in the array list, I don't need to do that. Okay? And if I use clear to array list, if I have array list which contains million objects, when I use a clear, I will get rid of everything. The garbage collector that's responsible to clear the memory, all these will be cleared. And you will discuss more about the ownership of the elements inside the array list. If the array list owns its object or not in 2030. But for now, we assume that all the object inside the array list is owned by the array list. So when we add it to the array list. When we remove it from the array list. Now, before we dig deep, I would like to define what they call it diamond syntax. These are two rectangles opposite to each other. So this is the way we define the array list. We can have the array list to the left. Then we have to put the diamond, which is the generic data types. You're going to discuss more in 2030 about it. And we say, I need the array list. Java need to know what type of array list that you are working with. And this type should be an object data type. In this case, is a string. I have the left side, I have array list, and then we have the rectangles, open and close, and we put a string inside these rectangles. And we give a name, it's called names, a new array list. And this is empty. In the previous version of Java, we used to have a string here and a string here. Now, by this line, I tell the Java compiler, I need an array list of type string. So I can store a string object inside this array list. How much the size of names right now? 0. If I ask for the size. Is the names dot empty how much? True or false? True. It's empty. I can use this list, as you can see here, I can use list as a reference type. Why? Because list is an interface and array list implement this interface. So I can use it as a reference type. I cannot create a new list. Remember, this is a mistake. I can create a new class. I cannot create a new object from the interface. I cannot say a list of a string, new list of string. No, I can use a list as a reference, but whenever I need to create, I create it from the array list. So the one in the here, these two lines are equivalent. These two lines are equivalent. So these are the one in the blue instead of the one on the top. But doesn't mean Java will not understand the backward compatibility. So if you use these lines with the string on the left side and string to the right side, still Java can understand everything is okay because the backward compatibility for the Java. But the ones on the blue is the ones that we are using. Yes? List is an interface. And ArrayList is a class. You create an object from the class. You cannot create an object from the interface. And the interface gives you a set of method, a set of behavior. So ArrayList will contain all the previous method that we discussed about the list, about adding at a specific index, removing, checking if the object is there or not. All these methods belong to the list. When I say that ArrayList implement this interface, that means all these methods exist inside the ArrayList. Okay, so this is what we call a diamond syntax. I would like all of you to understand it. So we can have ArrayList or a list on the left side. We have to put the open triangle and specify the type. We cannot define the ArrayList or a list without putting a type inside this diamond. Okay? When you have it here together, it seems like a diamond. That's why they call it a diamond syntax. Okay? Any question? So this is called a diamond syntax, as we mentioned. I can have a list of person, a list of students. As you can see, both are of type ArrayList. So I have a list of students that store inside the ArrayList. So I can have a list of rectangles. I can have a list of strings. So all these are new data types that we create and add it to the object of inside Java. So I can use collection of these. So inside the method I would like to, before I discuss, you see here, I have the triangles and this capital T here. Capital T, you can replace it with the students, you can replace it with the rectangle, with a string, okay? So I can ask, or an object here, is a generic formula for the array list. So I can add to the array list, I will have a return boolean if everything is okay. I can add a specific index. I can remove from a specific index, and once I remove, I will retain an object of type T capital, and in this case, T capital is a generic. It can be objects, any object, person, rectangles, students, strings, anything, okay? I can ask to remove, but I don't need the element. So here I remove the index. So I go to the index, specific index 2 or 3, and I remove the element at that index. I retain the element. Here, no. I give the element, the object, and I ask to remove, so I retain it true if the element is removed successfully or not. I can ask clear. I can ask for the size, and whenever I ask for the size, I have retained as an int. I cannot have an array list of 1.5 element, always integer type. I can have a get, I give the index. So there is a difference between remove at a certain index. When I remove, I will reduce the size of the array list. When I have get, I will just retain the element without changing the size of the array list. Set, I can go to the specific index and set the value, and I will retain the old value. I can ask for index of. I give the value of a specific data type and ask for the value. And it will retain -1 in case if we couldn't find the object that we are looking for. Again, we have a contains, give the object value, and we ask if the array list contains that object or not. It's empty, we can ask if the array list is empty or not, and in that case we have a true if the array list is empty and contains no elements. Example, as we discussed in the previous slides, we have array list of string or list of strings, and we give the name and we create using a new keyword, we create a new array list. So the advantage of specifying the element type inside the Java, here the compiler will start check for us whenever we would like to add an element inside this names list that is not the same as string. The compiler will allow us to check that before execution. So that is a very good advantage for us. So once you define a list of a string, you can only add or remove or change a string objects. You cannot have a list of a type of integer, let's say, and you want to add double to it. The compiler will reject that. So that is another safety features Java provided for you. Once you define a particular type to the left side, that this is a list of strings, so you can add a string, you can remove a string, you can replace a string, but you cannot add integers or add person to this list or rectangle to this list, because this list is specific for rectangle. Compiler will help you to do this. Restriction on the generic data types that some of you already mentioned that. So we can use all the collections, not only array list, all the collections, sets, maps, lists with object data types. We cannot use a primitive data types. So we can define array list of strings because a string is an object data types. We cannot define array list of int. This is illegal. So even the compiler will stop you from executing this command. If you try to define array list of int or double, that is a problem. Yes? It's okay because integer is a object data types. Okay? Yes? You can have object inside the array list. There's object data types. Oh, yes, you can. Because object is a parent class for any object that you create. It will be painful for you later on because you need to cast. Let's say you create a list of objects and you start sending a student, it will accept it. No problem. You start sending persons, it will accept it. Okay? Imagine you have a backpack and you put pencil case, you put papers, you put a box, notebooks, whatever you like inside your backpacks. So if I told you what is inside your backpack, okay, I have to open it and look inside to see what is it. And that's a human can do. But if you are doing with Java programming, creating a list of objects, by here saying, I take the string here, I put object with O is capital. So you create an array list with can accept anything. So inside your programming, okay, when someone asks you, get me the first element, oh, wait, I don't know what is the first element, I have to check. It's a person, it's a rectangle, it's a student, it's an integer, it's a string. So it's a very, very painful process. So that's why Java start realizing this problem. So that's why I told you it's good to specify a particular type at the left side. They say, this is ArrayList for a string. Okay, guys? So don't put integer inside it. Okay? So imagine you have your backpack, but rather than having everything in one, you have many slots inside your backpack. So this is a slot where the pencil case should be there. This is a slot for a textbook. This is a space for the notes. Okay? So Java start organizing this by making sure that the one on the left side is a specific data type. Again, there's a backward compatibility, because once they start releasing collections, everybody was happy. As you mentioned, I can put objects, so I have a list where the chairs is there, tables, students, person, employees, everything is there. Then they start realizing the problem when they pick it up. Oh, I have to check. This is an object of type string, or this is an object of type rectangles. After I check, I can manipulate it, because otherwise we will have a runtime error. And runtime error is very painful error. So they start doing it at the compiler level, tell you, okay, you have to do your job, specify what is the list is, and we can check it at the compile time, as we discussed on the previous slide. Okay, if you are interested to use a list of int, it's good to go to use the wrapping classes that we discussed on the previous lectures. Wrapping classes are the classes that start with capitals, like booleans. We have booleans as a wrapping class. This is the primitive data type. This is the object data type. So you can have a list of booleans, but in this case, P should be capital. You can have a start of characters, but C should be capital and the complete word. Not car, but characters. You can have short, where short is S is capital. You can have float, and you can have doubles, bytes. So whenever you need to work with the collections and you decide I need a collection of a primitive data type, it's good to using the object wrapping class of that primitive data types. Now, I think we discussed this, but we highlight it here on this slide, boxing and unboxings for auto class. So if I ask for array list of integers, as you can see here, I define array list of integers where this is a object data type integer, and start adding 42. List dot 42, add 42. So I will add to the end of the list. I will ask, give me the first element. So get will go and retain integer, not int. But Java starts realizing this issue and doing boxing and unboxing for us automatically. So in the second sentence, when I add 42, I add int data type, Java will take 42 and put it inside a box of object integers and give it to the array list. So now we have an object inside the array list. But me as a programmer, I send int 42. But Java from the back end take this int and put it inside the wrapping class integers and insert it inside the array list. That's what we call it a boxing things. Now, if I ask, give me the element at index 0, it will retain an integer data type. But Java starts saying, okay, we needed to make it simple for the developer and the end user, so we'll do unboxing. We open the integer data type and we grab the value and retain it as an int to the user. Everybody understand what is auto-boxing is? Any question? What we discuss here, integers, can be for the double, for the booleans, for any other primitive data types. Okay? Any question? Okay, so here we see we have integers and we get, I think this is the same slide, but we add here that Java automatically convert the object to the primitive data type, unboxing, or from primitive data type to object data type, which is boxing, automatically for you, it seems there's nothing happen on the back end, but that is what happened on the back end. Okay? It seems that I was able to store a primitive data type in the ArrayList, so the professor was wrong. No, Java do this for you automatically, so don't get confused. Here is we define array list of a string. We ask for the size. What do you think after this line, the size of the array list? 0. We start adding some element. As you can see, when I define the array list, I specify this is array list of string. So if I decide to add element that is not of string type, compilers will stop me. That's why we check it at the compile time, not at the runtime. So we add some elements. And also we ask to add at index 1. You can see here this array list allow us to grab object and put it at a specific index. That is the beauty of the array list. So I add, so what is this will be at which element? The first element will be what? ECS. So that will be at index 0, 1, 2, 3, 4, 5. Then I decide to add at element 1. So I will go to the element 1, I will add collections, and then I will shift everything. Is that right? So if I ask you to print what is the size of the array list, what will be the size? The size will be 7. Now, if I ask to print the array list, as you can see, because array list, I can ask directly to print the array list content. So I can print all the element inside the array list. Then I ask to remove element. As you can see, I have element of array, value of that element is array. I can ask to remove that element. Then I ask to remove element at 2. Then I ask for the size and then ask for the contents. So tracing a program like this will be the same as what you're going to do in the lab test 3. So I give you the program, add some element, remove some element, so I need you to understand the behavior of the array list. So in this case, we're going to go and remove the element arrays, the first occurrence. So if I have many element of value arrays, the first one will be removed, not all of them. And then I go to the index 2 after I remove the array and remove that element. So as you can see, when I ask for the array list, I have all the element. There is no double quotation here. Okay? When I print it, there is no double quotations. So that's when I ask you for the short answers. Don't I add any string data type? Because this is a print for the user. Here I add inside the program array list. I need to make sure this is array list of type string. So I add. But here there is no. So I remove array. Where is it? Here. It will be removed. Then I go to the index 2. 1, 2. This one will be removed. And that's what happened. Okay? Any question? So this example demonstrates how we can use the method of array list, adding to the array list, removing from the array list, ask for the size of the array list. Here we define a new array list of persons. So how I can go in the previous, I just ask print array list. What about if I'm going to go for each element inside the array list and print it out or do some changing or checking about equality or something like that? So I can do this for loop. I can do the for loop to go element by element of the array list and print them out. So if I ask you, we said that the array list care about the ordering. Is that right? Doesn't mean that the array list sort the item. So based on this one, which one will be printed first? Based on our discussion, array list, which element will be printed first? Did the array list change the order? We add P, then A, then C, then A. So we should expect P to be printed the first element, A is the second, C is the third, and A is the last one, or will be A, B, C. Is there any change? Will be, or it will be the same. We say that ArrayList care about the order. The element is added. But when, yes? No. It will print them in the same order that you entered them. ArrayList will not change the orders. The first element is added, it will be at index 0. The second one is added, will be at index 1. The last one will be at length minus 1 or n minus 1, the size minus 1. Okay? So the ArrayList care about the order but does not mean sorting the element. The element that is added first when the ArrayList is empty will be stored at index 0. The second one will be at index 1. So here we add P, A, C, A. It will be printed in the same order. Okay? Now, after we discuss the list, we're going to discuss the set. We have the tree set. So the set is an abstract data type that does not allow duplications. ArrayList can allow duplication. This is the previous slide. Is an example where you have the same person is added twice, person A. So you have person A is added twice. But in the set, we not allow duplications. So if you have element 1 and element 2, and element 1 is equals to element 2, and you try to add element 2 to the set where element 1 is exist, we're gonna ignore your request. Only one element will be stored. So it's very important to understand this, ignored. If you try to add the same element to the set, your order will be ignored. Your order will not generate an exception or a runtime exception. You think everything is okay, but the set will just simply ignore your request. Okay? So the difference between the list and the set, that the set keep the order the same. We add the element as we add them will be the same. But in the set, no, the order is mixed out. Because they have their own mechanism to guarantee that only one element will be there inside the set. So we can interact with the set by asking, adding an object and removing the object. Why we cannot ask remove element at index 0 in the set? We have this opportunity on the list. We can ask remove index 0, which allow us to remove element at index 0. Why we cannot do this on the set? Exactly. I don't know what is the index 0 is because the order is is mixed out. So that's why we only have add and remove, and we can ask if the list is contain this element or not. Okay, that's answer. The tree set. The tree set is different between the set. Is a class that keep the thing in sorted order. So they store the elements inside the nodes and they kept the sorted order of the elements. So that's the thing. So the nodes are arranged inside the tree shape, not on the linear sequentials. So I cannot guarantee the first element will be the first element when I add it to the array, to the tree set. But I can guarantee they are somehow sorted based on some sorting mechanisms. So we can have, again, as long as if you would like to use, this is a restriction here, if you would like to use a tree set because you are caring about the orders, which one is the greater than the other objects, you need to make sure that you have a comparable interface is implemented. and this is not our topic on this course. We will discuss it on 2030. So we're going to rely on some existing objects. Like you saw in the previous slides, I have persons, I have students, I have rectangles. If I need to use these objects inside the TreeSet, I need to implement the comparable interface, or I can rely on the existing one that is coming by default from Java, but I cannot guarantee everything will be in orders. So if you would like to use the TreeSet for any class, should implement a comparable interface. And the string is a class, object data type is created by Java expert, so it's already implemented comparable interface. Integers, doubles, all these wrapping class, already object data type, already implement a comparable interface. So we use the TreeSet if we want to visit a set element in sorted orders. Otherwise, choose the HashSet. HashSet is more efficient than the TreeSet. HashSet does not make any restriction, so any object can be used with the HashSet, but the TreeSet, there is a restriction that you should add only object with comparable interface. We can define a set of strings. We can use them as a reference set of string, and we can change between them. So you can see here, we can have a set of a string names, and we can define HashSet, and we can have a set as a reference data type names and define a TreeSet. This is an example where I'm using the TreeSet. As you can see, I add element P, A, D, C, and F. Now, and I'm adding them to the TreeSet. And we say that the TreeSet care about the orders. So the element with the low order, the list element, the smallest value will be at the beginning. Is that right? Because it's sorted out internally. Yes, I don't know what kind. I add the first one is P, then A, then D, then C, E, D, C, and F. There's no duplications. But what do you think if I print this TreeSet? What is the first element? Will be A. So we will have A, B, C, D, E, and F. And you know, these strings will be compared based on the orders of their characters. So they have a common characters, but the difference here is A capital, B capital, C capital, D capital, and E and F. And all these will be a Unicode represented as an integer value, and the integer value for A capital is less than B capital. So these strings at the end will be printed in orders. Yes? That is based on the implementation of comparable interface. Comparable interface will make sure that string A, which is the very smallest value of a string inside the TreeSet, will be the first element compared to other elements inside. So if I add now element with 000 strings with less number of characters, it will be in the beginning. Okay? You can test that at home. Take this example and change the value of the strings and see which one will be printed first. But remember, TreeSet implements sorted interface, which is care about the order of the element. But again, not the first element added means the first element printed. Okay? Did you see that? So who is the one is printed out? A, which is the very smallest string value. Any question? Yes.
So how does the TreeSet determine the smallest value?
Based on the comparable interface. And if you compare two strings, string A dot, you say compare, and you give another string, you will retain a value greater than 0 if this string is greater than the other one. Retain a value less than 0 if this string is less than the other one. Retain a value is equal to 0 if these two strings are the same. This is a comparable interface.
So is it
It's already implemented for a string because Java expert already created the object data type string for us. I can do it for you for the persons. Any object you create, you decide how you order them. For example, students. I can create a comparable interface where I can compare the students based on the GPAs. So the students with less GPA will be printed first. The students with high GPA will be printed last. I can compare the students based on their ID or based on their names. So comparable interface gives you this opportunity. Whenever you define a new data type inside Java, you implement the way that you sort the element. I can create an object of type chairs. Then I can sort the chairs based on the number of legs. The one with 4 legs would be the high. The one with 2 legs would be in the beginning. You see? So in the string data type is an object data type Java created for us. So Java cares for everything, for equalities. So that's why string.equals will retain true if you have 2 strings are the same. As you saw in the previous slides, when I say 2 persons are the same, I say I don't care about the name, I care about the ID for my applications. But maybe you, in your apps or in your application that you program, 2 persons are the same if they have the same name. Yes, you need to say this class implement comparable interface, and then you provide a compare method. Now, in 2030, we go beyond that. We say that within the same application, I need the different sorting. Sometimes I need to sort the students based on the first name. Sometimes I need to sort them based on last name. So that every time I go and change the implementation, we have another interface called comparator interface. So we're not going to go to discuss that. Now, accept what I said to you, that TreeSet going to sort them out based on their value. So if I have integer here, it will be automatically sorted for us ascending orders. Okay? You can try that at home. You create a tree set of integer object data type, and then add elements in any orders. Then try to print it out and see what's the result.
What if we add a string with elements / 0, which will be printed?
It will be the beginning. Try it at home. Okay? Now this is the HashSet. What do you think here? HashSet doesn't care about the order. The only thing care about it is don't duplicate the items. And if you try to add an item with the same value, it will be ignored for us. So the printing out, I don't know how. I have no idea until I run it and try it. And it happens that in your computer is different from my computers. Okay? So in this case, as you can see, did you see anything here suspicious? I don't know about the orders. I have no idea. So I don't know. I only think I know about that these elements will be inside. How they are inside, I don't know the order of printing. Okay, this is another example for a tree set. When I ask for a tree set, this is how I go for loops. This is an example to show you how you go for loop for each element to print them out. And also you can do something for each element, okay? And you can see here I do change the element. Here I ask to print the elements, okay? This back to the element. So you can go through this example at home and see how I define a tree set, and I use set here as a reference data type. I add element, I print the set, then I go through for loop for this and print uppercase. So working with the set does not have a duplicate items. So if you try to add the same element or a duplicate element, your attempt will be ignored. And we have contains to test whether the element is inside the set or not. So you can ask the names.contain Juliet or not. So here is the, as you can see, this example, I try to add element inside the TreeSet A, PA, then I try to add element F many times. So what do you think? How many elements will be the set? P, A, and D, E, C, and F only once. The compiler will not give me any exceptions by adding element F many times. If I ask if the tree set contains P, then remove A, just to demonstrate the behavior of contains. Then I ask for removing A again. The element is not there already, but I ask to remove it again. What do you think the output? Okay, so you try it and you see there's no compilation error here, even if I ask to remove A where the A is not there, so ignore the request. Good? Any question? Now, this question, array and list, remember the order in which you add elements. Set, do not. Why would you want to use set instead of array or a list? If you want the contains, you can have the list. There is a method called contains. I can ask the list if this element is there or not. Can anyone help us here? Yes. Yes. So the set, adding or removing element as well as testing the memberships, that is the efficient way of set. Okay? The set has an efficiency in terms of the implementation of adding and testing, because adding and removing element from the set is more efficient and fast compared to the list. And also, as you mentioned, if you want to check for a membership, if this element belongs to the set or not, it's good to use the set, because set has good mechanism to sort things out. Any question? Okay. Now going to the map, we say that whenever we come across an application where we have the key and the value together, it's good to use HashMap or TreeMaps. And what is the difference between the TreeMap and the HashMap? Is again the difference between the HashSet and TreeSet. The TreeMaps implement what we call a sorted map. So care about the sort of the element, while the HashMap does not. So sometimes we want to store data in an organized manner where it's allow you to quickly find the elements. It's like a dictionary. When you go to the dictionary is sorted out for you. If you have a word that you would like to find the meaning for it, you go over the index. You start with, let's say, Z, then you go to the letter Z, then W, then you go to the letter W, then until you find the definition for the value. Again, your phone box inside your phone is sorted in the same as a map between the name and the phone number. So it's some kind of dictionary. Whenever you come across the key and the value, that is where it always should come to your map, to your mind, that I have to use the map. Now, the map elements, okay, and the value elements can be anything. So don't restrict that always the key should be integers or objects. No, the keys can be any object data types and the values can be any object data types. So you can make a pair between two objects. Okay? So here is the example. You have the phone number and the name corresponding to the value. So you can use this phone number as a searching key. Here you have the name and the color, the favorite colors. I like green or blue or red. And as you can see, the key, there is no repetition inside the key, but the value can be repeated. So the map, it's what? What's this map is? What's this relation? 1 to 1? This is 1 to 1? 1 to 1, many. Because, or you can say many to 1. This you're looking from this, from the color to the keys. The value can be repeated, but the keys can be only unique. You cannot have duplicate inside the key. Okay? You cannot. If you're using the name as a key, the key should be not duplicated. You cannot add the same key to the same map. Okay? Because the map is a set. The key is a set. If you're trying to add something to the set with the same value, it will be ignored. I told you, based on your application, you have to use the key, a very meaningful attribute that is not duplicated. So, for example, here, yes? Yes, you can, it has a many, for example, in Python, they call it dictionary. Okay, you can have a different name on different programming language, but here we call it a map inside Java. So here a map, we define an object string, and then you give a name and you tree map. So you make a link between the key and the value. The key is a set. The value can be any collections. Yes? Juliet will be a key. So you cannot have the same key again. Is not the uniqueness for the combinations. Okay? So you can try it, but again, if you understand the set, I'm telling you the map, the key is a set inside the map. So if you have the set and you saw in the previous example, I tried to add element F many times. Did they accept it? Yes, it's accepted, but there's no allow you to have a duplicate inside the set. So if the key is a set inside the map, so I cannot have duplicate inside the set. Okay? These are the methods that interact with the map. Whenever you need to add, you add both object as a key and associated with the value. So you have here, as you can see, the keys are the names and this is the numbers. You can have this name and the value, you add it to the map. Okay? You use the name as a key, so the keys should not be repeated. You can have different names but with the same value, it's okay. You can remove the key. You can go and search for a particular key and remove it. It will retain the value for that key. You can ask to remove an object. So we're going to look for the objects and remove the value. In this case, we're going to remove the key and the value pair associated with the key from the map, and usually we associate with the key and we retain it. So you can see here we're removing the pop value from the map. We can ask for the size. It will retain the number of keys because these keys are not allowed to be duplicates. So if you have 10 keys, that means you have 10 elements inside the map. We're not allowing a duplicate for the keys. Keys are sets. Now, you can ask for a clear for the map. So it will remove all the elements from the map. And when I say element, I say the association between the keys and the values. You can ask if the map is empty. You can ask if the map contains a particular key. So it will look inside the map and return true if the key is there. If the key is not there, it will return not false. You can ask if the key or the map, if the map contains a particular value by asking contains value. In this case, you give an object K and you ask if the object K is inside the map, and then you remove it from the map. As you can see here, we ask if this 55-111 inside the map, we're going to go and remove that element from, we're not removing, we're asking if this contains the value. If the value is not there, we're going to return false. Any question? So all these methods are coming from the map interface. So the hash maps or tree maps will contain this method by default. We can ask for the key set. So if you have a map defined, you would like to have the set of the keys, then you can retain all the keys inside the maps. You can ask for the values. It will retain a collection of the value. Remember, the value is a collection. We can have a repeated value. So that's why we retain a collections of the values. This is an example of tree maps where you have the name associated with the color. You can ask to put the name and the color. What do you think here will be? We will add a new record inside the map. So we added Juliet with the red. Then we can change the value of Juliet inside the map by asking both Juliet and blue. We can ask retain the value. The value of the color is a string data type. So we can ask what is the associated with the key Juliet is the color is, and we retain a string data type. And we retain null if the key is not there. We can ask to remove a key, and it will remove the key and the value together. Now, HashMap and tree maps implement the map interface. And as we said that the difference between the HashMap and tree map, the tree map keep or implement an extra interface, which is a sorted interface. We keep things sorted. So the HashMap is an efficient for locating the value inside the map and deleting from the map. The tree map is implement a sorted map interface, so keep things is sorted orders. Now this is an example where you have association between the string and integers. So the string is the key and integer is the value. So we can have these associations, the map, which is the name of the students and the grade value. The value or the grade for each student. So here is the name of the students as a string. And the value is the grade of the students or the integer value. Now, if we ask the tree map to print this one, what do you think the print will be? Remember, the tree map implement the sorted map interface. So it will keep things sorted. So what's the output in this case? We'll sort out the keys. And then we ask the map dot get the value. So what's the retain here? We give the key value, we retain the value associated with this key. And if we ask the John, we retain the value associated with the John. So we'll print the map based on the sorted keys. So E come first, then J, then we have M, then we have R, then we have W. And if you ask the map to be printed, it will be printed as a pair, the key with the value. So the key even equal to the value 100. The value can be repeated inside your map, but the key cannot be repeated inside the map. Now, if I ask the value for the key that does not exist inside the map, I will have null as a retain. If I ask the value for the key inside the map, I will have the value associated with that key. Any question? This is another example where you define the hash map and you start adding the name of the city and number associated with that city. So we put inside the hash map. And once you put inside the hash map, you're not caring about the orders. You care about the performance because the hash map is performed better than the tree map in terms of retrieving and deleting the element inside the map. As you can see, this is another way of creating a hash map. Then you give the hash map inside the constructor of a tree map. So I can have the hash map. I would like a tree map from, or a copy of this hash map, but inside the tree map. So I can have my own hash map is already created. I don't need to repeat all this process again, creating the hash map and adding elements to the tree map. No, I can have the constructors automatically taking an existing hash map and create a tree map from that hash map. As you can see here, the tree map is created based on the hash map that I already create in my application. Then I ask to print the tree map. After I create the tree map, I ask for a set of keys. Remember, whenever you ask for a set of keys, the retain type is a set. So you have to receive it with the set of a string, a key of a string. So the set of keys of maps is actually of type set. So I create a set keys of type set and then string. And then I can go iterations inside the keys to retrieve the values and print it out to the user. So in this example, you will see how I create the hash map. And from the hash map, I create the tree map. How I retrieve a set of keys of a certain hash map or tree maps. And then how I can go for loops inside this key set and either get the value of these keys, change if I would like to change the value of the sets or not of keys, or investigate for a particular value and change it. So this will be printed out as a output. So it will sort out the element. Okay, this one, if you see here, this is the hash map, and we say that the hash map don't care about the orders. It care about if the element exists or not inside the hash map. So you can see here the printing in some kind of random order. You cannot predict it, but the printing for the tree maps, it's based on the sorting of a string. So P capital comes before L, N, P, and S capitals. So you know how things will be printed. If I ask you on the test, this is the tree map, I'm going to print the output of the element of the tree map. You know that the tree map care about the orders. So it will print the strings based on the order. If I ask you about the hash map, nobody can predict the orders of the printings. As you can see in this, I go iterations through the elements of the map and print them out to the user. This will discuss what we call a collections toolbox. I have a question? If I ask you for the hash map, for example, print the hash map out, what's the output of printing? I cannot predict the output, okay? Maybe the most important thing is to let me know that this element exists only once inside the hash map. But in the tree map, I care about the order, I know how and also on the tree set, I know how the output will be. Tree map, tree set, I know the output. Hash set, hash map, I don't know. Now, this collection toolbox, which is a collection class, don't get confused between the collection interface and collections class. This collection class will allow us to do a lot of code. This is like a math class. It's a statics class and has some sort of methods receive collections as an input. For example, I can do binary search. Collections dot, I can ask collections like math dot cosine, math dot sine. I use that in my code. I can ask collections dot binary search. I give the array list and I give the value and do the binary search inside the list. I can ask sort, collections dot sort the list. And I can reverse, I can shuffle the array, I can swap, I can replace also. Let us see the examples. Maybe it will be, so this is set of algorithm is already implemented for us by the Java expert. So let us see the example. I define an array list of integer data types. This is an object data types. I add element. As you can see here, I add element 13, 3, 5, 1, 34, 19, 222. Then I ask collections dot sort. To be able to use these collections, it's good to have import statement, and this is what mandatory. Even the Android Studio, if you try to define an array list or a set, it will give you that in red. You can press Alt, Int, and integer and then add it automatically, or you can explicitly write import java.utility.start semicolon. This will import everything for you. So you can ask collections.sort. This will do the sorting. So rather than going to the element, and it will sort the element and store them back on the same position. So you don't need to receive the output of the sorting. It will sort the element inside the collection itself. This is a good thing. So we will print the element and sort it. Why we can do this? Because integers implement comparable interface. If I define a list of persons class, I didn't implement the comparable interface. I ask collection.sort. I cannot predict the output. Okay? Because I didn't implement the comparable interface, which is allow me to sort the persons in a certain orders. Here, I know this integer data type, object data type, is already created for us, and the sorting will be in ascending orders. If I define a string, I can sort the string based on their alphabetic orders. Then I ask shuffle the array again. This will shuffle all the array list and print them out. Then shuffle again and print them out. I can ask for the maximum value and the minimum value. Here, this example, I work with integer data type. I can work with any object data type. I can work with rectangle data types. And I can decide to sort rectangles based on the area. Then I can retrieve the maximum rectangle based on the area, the minimum rectangle based on the area. Okay? I can sort the rectangle based on the width, and then I retrieve the maximum based on the width. I can sort them based on the height. I can define students and retrieve the maximum based on their GPAs, if I sort them based on the GPAs. So different ways, but this example to highlight the power of collections toolbox that Java expert created for us with some standard algorithm is already implemented for us. So you don't need to implement sort algorithms for you. So once you ask collection.sort, it will sort the collections for you. This is the output of the program. If you shuffle the array twice and then you ask for the minimum and the maximum. This is the students. For example, I define an array list of students and I can ask for the sorting and all of this. Now I have a students here list but defined as a string. So what do you think? We will sort the string based on their values. So we will sort the string based on the values. String one, student 1 and 13 and 19, 22, all this based on the value of the string, character code. Then I can shuffle them, ask for the maximum. The maximum was student number 5, because based on the string value, okay, the ASCII value. Now, how I can go through the collections, we saw this slide just to highlight how I can go. I can ask for the for loop for the object inside the array list, or I can ask for the persons. So this already we saw this on the previous. I will go over this one. You have iterator interface, which is allow you to ask for the next items of the list. Okay. This slide will discuss the performance. I left it for you to look at it. It will retrieve the time. It will make you sense what is the one is efficient. We're supposed to discuss this example, then jump to the time complexity. We will leave this for the next lectures. We'll discuss this example. But I would like you to take this example and try to implement it at home and see the result. In this slide, you see that if you are using the HashSet, you have 3 milliseconds. Okay? And if you are using the link HashSet, you will have 1 milliseconds to do the set operations. Now, here is the TreeMap. You need 5 seconds. 5 milliseconds, 6 milliseconds, and you can see if you want to test the time for ArrayList, you need 82 seconds. Each one of these is retrieving and setting the element inside the HashMap, and you can see which one is the efficient in terms of time. And this simulations is, I recommend all of you to take this simulation and implement it and see the difference. Okay, meantime. Next time we will discuss the computational complexity, and it will be our last lectures.